Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at a part of a series of videos that fall under the fundamentals demo. In this case, what we're going to do is we're going to take a look at one of the examples from our textbook. So this video assumes a couple of things. Number one is that you have your C environment set up correctly. And number two, that you have a copy of the textbook that we're using, which is our Problem Solving and Program Design in C by Jerry Hanley and Elliot Kaufman. Doesn't really matter which version you have, but we will like to borrow a few examples from their text. Should this become a copyright issue, we will just switch out our examples. But essentially, they just provide some nice documented examples that what we're going to do is we're going to modify them to use in our code. Specifically, we want to take a look at the figure 1.13 in chapter 1. So the first thing I want you to do is I want you to go to File, New Project. I want you to create a C and C++ application. And in this case, I want to call it figure_1_13. Now, we are not going to be able to use additional periods. And also, as you're going to see, we cannot or should not be using spaces as well as any other unusual characters. We should stick to alphanumeric plus underscore. Now, as far as the main file, you can leave it as main, or what we can do is we can also call this one figure_1_13. But in this example, I'm just going to go ahead and leave this as main. Once again, that means template is going to provide you with a main.c. You can change the template, but what we want to do is we want to utilize the contents of our textbook here. And in this case, I've appended a file header that gives credit to the authors, specifically to the Hanley and Kaufman here of our textbook. And so I want to go ahead and copy this over. It's always important to give credit where credit is due when it comes to programming. And we'll talk a little bit more about that later on. As far as the rest of the contents of the file, you can acquire a copy of it or copy it or type it out of our textbook. Either is fine. Essentially, what we want to do is we want to look not so much at this particular code, but at the process of where to put your code. And so you can pretty much at this point use any code that involves a printf or a scanf. So we're going to go ahead and paste this in. Notice I'm just overriding the main that was provided for us by NetBeans. Now, before we go any further, I want to go ahead and build, make sure that we don't have any typos from our copy. Once again, you can either acquire a copy of this file or simply just type it in from the textbook. Notice I have a successful build, so it looks promising. So what we can do is we can now go ahead and focus just on this version. We'll come back to that main, the figure 1.1_13 in just a second. So the first thing that you should notice is this is using a little bit different format than what we have in our previous examples. Particularly, you'll notice that the author is declaring a couple of variables here using multiple lines. And so it's indicating miles and kilometers that are both of type double. He's doing it on separate lines. That's a pattern that we are not going to follow. We're going to declare each one of our variables on a separate line, at least until we get familiar enough with programming. The second thing that you'll notice here is that this example, in addition to the printf, also has a scanf. A scanf allows for you to enter in information from the console. In other words, we prompt the user with a printf. In this case, the author does not use a new line, but rather a greater than symbol. Once again, personal choice that we are not going to follow. Once again, nothing wrong with the author, nothing wrong with the book. It's just certain patterns that we are going to differ slightly on. But I wanted you to see an example from the book so that you can sort of relate to how you can use the book in this class. And then once you've acquired the value from the user. In this case, we have put it in our miles variable. Notice we have an ampersand in front of it. We're going to come back to this later on, but this means that we're storing the value collected from the user at the address or at the location of the miles variable. In addition to that, you'll notice that our scanf has what is referred to as a format specification or a format spec associated with the data type. And so in this case, the %LF indicates that we are trying to get a double value or a numeric value from the console. So anything else will not be accepted. Lastly, then, what you'll see is we do a simple operation involving this KMS per mile, which is a constant that was declared in our pre-processor directives. By the way, when I copied and pasted, I just noticed that I accidentally included the earlier includes. We only need to include standard IO.H in this particular example. And if you'll notice here, standard IO.H is actually the location of the printf and scanf definitions. So what you can do here is you can right click, navigate, and go to declaration definition. And if we do a control F, we can actually find the scanf. And so you'll see where scanf then is referenced in the .h file. Likewise, in main, assuming that your main or your source file is larger, whenever you see a constant like this, you can actually right click on the constant, navigate and go to declaration definition, and it will actually show you where, in this case, the constant is defined. So the constant in this case is merely the conversion between kilometers and miles, 1.609. This is not terribly different from what we saw in an earlier video with exit success and exit failure, but you see the pattern is that you use the pound defined keyword followed by the constant name, followed then by the value. Lastly, we simply print out the results stored in the KMS variable. And that KMS variable is updated when we multiply the miles times the constant. Notice prior to the scanf, where we store the value in the miles variable, and prior to the calculation where we update the KMS value, these variables have not been initialized. In other words, the values that are found in these variable locations is essentially junk or garbage. It's unpredictable. So what we've done here is we have declared these variables first, and then we've used them. We'll come back to this again in a later video, but it's important that you remember that that is a two-step process. The declaration of the variable simply allocates memory for use by the variable, but does not initialize the value. Quick way of thinking of that is if you declare a variable, but you do not initialize it, essentially what is in that variable is garbage or useless information to you. It could just as easily be values from that memory location from the previous time the application was run or from some other portion in code. So, quick overview before we compile it and then jump out to the command line. Basically, we are declaring a couple of variables, a miles and a kilometers, KMS. We print to the console a prompt to the user. We collect information according to that prompt from the user using scanf of type double. We store it at the address of miles, and we do a simple calculation using the constant, and then we turn around and print out the results. The only significant departure from what we have been doing earlier is that we used our exit success and exit failure. In this case, remember that exit success is actually 0. So essentially, this is doing the exact same thing. The other minor thing to note is that unlike our earlier example, the main here accepts no input arguments. This is another departure that we will be doing in our code. We are going to use another function signature for main. But aside from that, let's go ahead and build it. Let's go ahead and jump out to our command line We're going to CD using the ... to go back a directory, depending on where you're at. And we are going to go find our figure 1_13 project. So CD figure 1_1_13, the distribution folder, debug, MinGW. And then now you see there's our executable, which if we run it, the first thing we get is a prompt for enter the distance in miles. I'm going to keep this simple. I'm just going to put 1.0, and you'll see that that's equal to 1.609000 kilometers. Notice that we have more significant digits than what we had what we had anticipated, I guess you could say, and that is just simply by virtue of the fact that this format spec or printf doesn't really control the formatting of the floats, the default for the double rather. So we'll come back to that as well. There's plenty of opportunity for us to get this right. But what I want to do now is I want to take a look at how we can introduce this code into our fundamentals demo. And more importantly, I want us to see how we're going to manage our future projects. So what I'd like for us to do now is to just drag this main over. And then I want us to focus on our fundamentals.c that you should have completed in an earlier video. And particularly, if you recall, we talked about the function and the 3 steps to creating and utilizing one, particularly the function prototype, which was the contract, then the actual writing of the function or the implementation, followed by calling the function. And so what I'd like to do now is I'd like to go into our main, and I would simply like to comment out our get info example. So as of right now, if I were to compile this code, and if I were to come back out to the command line, and now I'm going to take a second to change directories one more time. By the way, you can actually change up multiple directories by just providing the \. So in this case, I have went up 3 directories. And now what I'm going to do is I'm going to go back down my fundamentals demo project tree, into my distribution, into my debug, into my MinGW. And there's my fundamentals demo, which if I run, does nothing. Why does it do nothing? Well, because main doesn't do anything. So regardless of the fact that we have declared the prototype and we've actually implemented the function, we never actually called it. So from there, we can fix that by simply uncommenting that, but that's not the purpose here. Instead, what we'd like to do is we'd like to go back to the main.c of our figure 1_1_13. And what I want to do is I want to copy the contents of the main, and I want to paste it into this main, just a direct copy. And at this point, then you should get an error that says that the KMS per mile is essentially unable to be resolved, which effectively means that we have not declared that constant. And so if you hover over it, you'll also see unable to resolve identifier KMS per mile. No big deal. We simply come over here and we copy and we paste our constant. And the constants can be put in wherever we want, as long as it's before the main. And typically they follow the includes because you may use them in your function prototypes. So in this case, then there is our constant. If we build this now, we should now have a fundamentals demo that compiles and ideally should run. And what we can do now is we come out to the console and we can once again type in fundamentals_demo.exe or simply hit the up arrow, and you'll notice that you're getting the same prompt that you would have gotten in your figure _1_13. In which case, we're going to put in 1.0, and sure enough, that equals 1.609000, just like we saw earlier. So far, so good. But what happens if you want your executable to do more than one thing? This is where the problem arises. If you put things in main, in order to be able to get main to do multiple things, you have to comment and uncomment. And that's rather unwieldy. It's actually kind of awkward. So what we'd like to do is we'd like to push this particular example out to a function. And so if you take a look now in chapter 2 of the book, the author has done similar to that, but we're going to take this a little bit further in that we are going to completely encapsulate what was figure 1_13 into a separate function altogether. And I'm only going to do a few examples of the books in these YouTube videos because I would like to allow the author then to give his own take on his work. So I'm not trying to infringe on any copyright here, but rather I want you to feel comfortable with how you would interpret the code in the book. And so in this particular example, what I want to do is I want to have the return value, and I'm going to simply follow the pattern that we have in our textbook. And that is, if you notice that each one of the figures are capitalized, so capital figure, and then wherever there's a space or a period, I'm just simply going to replace it with an underscore because we cannot use those in our function names. So it's going to be figure _2_1. And for this particular one, we want to accept no input argument. So we simply have a void for an input argument. And so what this does is this will run the code associated with figure 2_2_1. And actually, you know what? I'm going to change this ever so slightly. Is instead of using the word run, because I want to relegate the word run to when we're actually running a particular function, I am just going to say this handles the code or handles the demo code associated with figure _2_1. Because remember, this is merely a contract. This says that you want to do this. Now, what we want to do, or what we can do, is very carefully copy this function prototype, and then down below our get info, we can simply create another function called int figure _2_1, and instead of the semicolon, we simply put a set of curly braces. And like in our previous example, we can follow that up with a return exit success. And if you recall, exit success is just simply a constant for 0. So far, we haven't really done anything different than what the author is wanting to do. What I'd like to do now is I'd like to take the code out of main. And so in this case, I'm going to use Control X, and I'm going to paste it into the figure _2_1. And I'd like to make a few other minor changes just so that you can understand how we're going to go about doing it. First, we're going to use exit success and exit failure, but we're also going to, rather than declare these variables on a single line, we're going to use multiple lines. Once again, in your professional environment, you may do things differently, but for right now, for this course, I'd appreciate if you follow up with the way that we are doing it. Continuing on, about the only other minor change that I'd like to make is I'd like to control the output just a little bit more. And we're just going to start off with a %.4f, just to see how this changes our example a little bit. Other than that, the rest of the code is going to stay the same. Note that our KMS per mile is still valid because it's a constant over the entire C source file. And so if we save this and then we build it, hopefully we should build. And if we come out here to the command line, we hit the up arrow and we hit enter and we get nothing. Now, hopefully in the back of your mind, you were talking to the screen telling me I had forgotten to do something. And if not, take a second to pause the video and look at your code and see if you can figure out, what did I do wrong? Well, hopefully you figured out that what I did is I declared or wrote the prototype for my function. I wrote the function, but I in fact never called it. And so in order to actually execute our function, we need to come back into main and we simply type in the name of our function. Now, if you've got a really good memory, or if you followed a pattern, you know that it's figure_2_1. But if you're like me, you don't really like to remember stuff like that. Instead, what you want to do is you want to utilize NetBeans and utilize the tools of an advanced IDE. And to do so, you simply hit the Control and the space bar, and NetBeans will attempt to find every function that matches those first few letters. In this case, my figure_2_1. And it also tells me that it's expecting a return value of an integer. And we'll come back to how to handle return values in a little bit. But if you hit Tab, followed by a set of parentheses and followed by a semicolon, we can then say calls our function, but more specifically, it calls our demo of figure_2_1. So far, so good. Let's go ahead and build it. And then if we come back out here to the command line, we run it, and sure enough, we get the code, enter the distance in miles, or rather we get the prompt, enter the distance in miles. Once again, we're going to type in 1.0, and it returns back that equals 1.6090 kilometers. Now, a few other minor changes, just aesthetics, but I'd like to show you what I would prefer to see. I know why the author likes to see this style. This is sort of an older style, and I've used it myself in the past, but I would like for us to make one other minor aesthetics change, and that is after the enter distance in miles, I'm going to put a colon followed by a new line. And then go ahead and save it, go ahead and build it. And if we hit the up arrow one more time, you'll see that I get the prompt, enter the distance in miles, type in 1.0, and I just personally think this is a cleaner output. Once again, we're not necessarily here to learn my personal preferences, but just be aware that's how you can modify then the user's experience. So hopefully you found this video useful. As always, if you have any questions or comments, don't hesitate to email me. Thank you for watching.